say so that is for a function of single variable. For a function of single variable, a is a critical point where the first derivative is 0 and the sign of the second order derivative determines whether the critical point is a point of local maximum or a local minimum. Natra. For a function of one variable, it is the sign of the second order derivative that determines if the value of the function at the point is maximum or minimum. So, for a function of two variables, local maximum or local minimum or the sign of the second partial derivatives. I repeat, the signs of the second partial derivatives of f determine whether f at AB is a maximum or a minimum. Second partial derivatives for a function of two variables. For a function of two variables, the signs of the second order derivative determines whether at that point the function has a maximum value or a minimum value. Important point so that so important point so let f of x comma y be continuous. And let all its second order partial derivatives okay. Second order partial derivatives be continuous. Throughout some neighborhood of the point AB. Let the function be continuous and let all its second order partial derivatives be continuous throughout some neighborhood of the point AB. Furthermore, let us define a quantity which is called capital D AB. Let us define a quantity which is capital D AB. DAB, this is defined as the second order partial derivative with respect to x calculated at the point AB, or fxx the x differential multiplied by fyy calculated at AB. This is partial derivative with respect to y taken twice. There we go. Okay. Fxx calculated at AB multiplied by fyy calculated at AB minus fxy square. AB, B. Sila amuk, sila kay haiba y ki matung ina mo differentiate over x ki matung ina mo differentiate over at AB. So define those. Let D be defined as this. If the first order partial derivative with respect to x at the point AB is equal to 0 and Fy at AB is also equal to 0. Have you know AB is a critical point or the function then FAB, the value of the function at the point AB will be harga number 1 a local maximum of a local maximum if Fxx AB is less than 0 and DAB is greater than 0. Siniko x ki matung in a partial derivative is less than 0 and this quantity D, this is greater than 0 at the point AB. So already local maximum organi number 2 a local minimum if f xx a comma b is greater than 0 and dab d a comma b is greater than 0. This is local minimum. Aduna fxx na positive already local minimum. dab is the positive. Number 3 a saddle point if d a comma b is less than 0. Aduna d is less than 0 already point a b is saddle point already. Number 4 if d ab is equal to 0 higher partial derivatives must be considered. So these are the conditions for the point to be a local maxima. So see, I'm going to repeat. Okay, let f of xy be continuous and let all its second order partial derivatives be continuous throughout some neighborhood of the point AB. Furthermore, let us define a new quantity d, which is defined as fxx multiplied by fyy, both calculated at the point AB, minus fxy squared calculated at the point AB. This is the quantity which is called d. If fx AB equal to 0 and fy AB equal to 0, have it if AB is a critical point, then the value of the function at the point AB will be a local maximum if fxx at AB is less than 0 and d calculated at AB is greater than 0. If fxx is greater than 0 and dab is greater than 0, the function will have a local minimum at the point AB. DAB is less than 0. If DAB is less than 0, then the function has a the function has neither a maxima nor a minima at the point AB. The point AB is called a saddle point. If DAB is 0, higher partial derivatives. So see idea. So this is how we check whether a given function has maxima, minima, or a saddle point. So we can consider one example. Example of my consider Tarasi. Okay. Let us consider the example given by f of x comma y is equal to x cube plus y cube minus x minus 6y plus 10. Let us consider this example. Sigi example ji discuss tawrasi adudagidi. First, my critical points ma'am here. We will find the critical points of the function. Then at the critical points, we will check whether the function has a maximum value or a minimum value. Aduna so the functions the equations for the critical points are critical point की equation जरी करी ना critical points की equation जरी del f by del x equal to 0 del f by del y equal to 0. Critical points or the partial derivatives of the function calculated at this point should be 0. So this implies, let us take the partial derivative of this expression with respect to x. This is 3x squared minus 1 equal to 0. This implies x squared equal to 1 by 3. So this implies x equal to plus minus 1 by root 3. Very good. Del f by del y equal to 0. You differentiate this with respect to y. This will give you 3y squared minus 6 equal to 0. This implies y squared equal to 6 by 3, which is 2. This implies y equal to plus minus root 2. So there are two possible values of x and two possible values of y. So how many different combinations do we have? We have four different combinations. Therefore, the critical points are x की positive value lorosi, y की positive value lorosi. So 1 by root 3, comma root 2. This is one critical point. Another critical point, x की minus 1 by root 3 loro, minus 1 by root 3 loro, y gina plus root 2 loro, plus root 2. So, sigi possible any value, any sigi possible value, any problem for 4 different combinations. These 4 different combinations will give you the 4 different critical points. So amuk 1 by root 3 loro, minus root 2 loro, yareko. So the minus 1 by root 3 loro, minus 1 by root 3, minus root 2 loro. So 4 different combinations are given by this. So these are the 4 critical points of the given function. These are the 4 given critical points. Sorry, these are the 4 critical points of the given function. Critical point Mari Ziki Manunga, function Ziki make local maxima and Karamano, local minima and Karamano, saddle point and Karamano. So to identify the local maxima, local minima in the saddle point, what should we do? We should remember what we had just written a few minutes earlier. It is this. D I'm going to define Taroni fxx fyy minus fxy square. D I'm define Taroni adulagi fxx ki sign D ki sign. Aduga different possibilities local maximum or BI, local minimum or BI, saddle point or BI. So first let us calculate the second order derivatives. What does it got? So let us calculate the second order derivatives. So now fxx, fx this is fx. Fx the fx have the partial derivative of f with respect to x, which was 3x squared minus 1. Now fxx means you differentiate this again, 3x square minus 1 with respect to x. 3x square minus 1 with respect to x differentiate 6x. Now fyy. Now let us calculate fyy. What is del f by del y? Del f by del y is this 3y square minus 6. Now you differentiate this again with respect to y. What do you get? 6y.
6y.
f xy. The fx we could differentiate again with respect to y. So what is this? Fx 3x square. If you differentiate this with respect to y, it is 0. Now fy you differentiate it with respect to x, which is again 0. So fxy is 0. Therefore, already d formula it was equal. D equal to f xx dlab is equal to fxx calculated at AB, fyy calculated at AB minus fxy whole square calculated at AB. fxx magi value di kayo 6x. fyy magi value di kayo 6y. Yarba. Aduna si AB higher again, si kano higher again. xy higher again. This is calculated at xy. Oh, this is calculated at xy. xy. So what is this? This is 6x. What is this? This is 6y. What is this? This is 0. So this will be 6 into 6, 36 xy. So the value of d, the value of d is 36 xy. 36 xy tare. Ado regadi khoi ngasai critical point bari to the khoi yang aseba. Thus at let us consider the first critical point at this critical point. Thus at this critical point at 1 by root 3 comma root 2. D value change. So you take x C A nico, so B nico. So DAB x motor A since the law, y motor B since the law. So this will be x motor 1 by root 3, y motor root 2. 1 by root 3, root 2, both of these are positive numbers. So 36 multiplied by positive number is again a positive number. So D is greater than 0. What is important is not the value of D. What is important is the sign of D. D value do D is sign do. So D is greater than 0. Then D is 0. This is our settle point. It can either be a local maxima or a local minima. So D is greater than 0. And D is not 0. This is our let us check the sign of fxx. Fxx sign zero. Fxx. Fxx is 6x. 6x. But the x can 1 by root 3. So when x equal to 1 by root 3, 6x will be a positive number. So this is again greater than 0. Therefore, the function has a local minimum. Local minimum. Sagi hojiki mamang da laihiduni ko. Hojiki mamang da laihiduni. Sige local minimum kram kando hoigani. Fxx is less than 0. D is greater than 0. So D is greater than 0. Fxx is greater than 0. So this is a local minimum. Local maximum hoigana. This would be less than 0. Next time we are going to see at the next point. At the next point, what is the next point? The next point is this. At minus 1 by root 3, comma root 2. So at this next point, what will be the value of D? D xy natra. D is xy. 36 times xy. Here x is negative, y is positive. Therefore, xy will be negative. So 36 multiplied by a negative number will be a negative number. Therefore, d is less than 0. D is less than 0. It is a saddle point. It is a saddle point. F of AB will be a saddle point if will have a saddle point if DAB is less than 0. DAB is 0. The saddle point. So here at this point D is less than 0. Therefore, this point is a saddle point. Now let us look at the third point. 1 by root 3. 1 by root 3 and minus root 2. Here again, D is 36xy, x is positive, y is negative, therefore D is negative. So D is again negative, therefore this is again a saddle point. Now let us look at the last point, which is minus 1 by root 3 minus root 2. So let us look at the last point, minus 1 by root 3 comma minus root 2. Here, both here minus 1 by root 3 and minus root 2. Here, both x and y are negative. Negative multiplication xy will be positive, and 36 is again positive. So D is positive, and D is positive. And what is f? F of xx? F xx is 6 times x. Here x is negative. Here x is negative. Therefore, f xx is less than 0. D in a positive order, f of xx in a less than 0 order, a local maxima. Maximum. So for this given function, the equations for critical points are given by these equations, and we have found 4 critical points. And at these 4 critical points, we have calculated the values of D. When D value fxx fyy, and depending upon the signs of D and fxx, we have identified the points as points of local maximum, saddle points, and points of local minimum. I think we can stop here for today.